Hi, and thanks for giving me this opportunity to talk to you. My name is Jackie Baltes. I'm a professor in the Electrical Engineering Department at the National Taiwan Normal University in Taipei, Taiwan. And I'm going to introduce my lab, the Educational Robot Center, short ERC, at Ntnu. We're an international team of researchers. We regularly have visiting professors from other places. We have a postdoc from Korea and PhD students from Korea and Brazil, and also master students from Taiwan, Indonesia, and Brazil. We also have internship students from Singapore and India join us for 4 to 6 weeks during the summer sometimes. My research area is intelligent humanoid robotics. I consider myself an AI researcher. That's where I got my degree in at the University of Calgary. But I'm not so much interested in stronger motors or better sensors, but in making these robots behave intelligently in the real world. To that effect, we also do a lot of work on machine learning, computer vision, and other areas of artificial intelligence. One area that me and some of my colleagues are very interested in recent years are robot competitions as benchmark problems in order to prove that our research is moving in the right direction, to check what progress we're making, and to show to the general audience the state of the art of robotics. To give you an idea of the kind of work we're doing, I first introduced the robots that we have available in the ERC. One is a Robotis OP2 robot, about 45 centimeters tall, so it's a relatively small humanoid robot. We also built our own 80 centimeter tall humanoid robot, another 1.3 meter tall larger adult-sized humanoid robot, and our largest and most complex system is the Thormang robot, developed by Robotis company from Korea. All of these robots receive most of their information about the world through the vision system. So they all have cameras, and to balance they use IMUs, gyroscopes and accelerometers mounted in the torso of the robot. The robots also have all been very successful at the various robot competitions, so we won several first, second and third places. As far as the competitions are concerned, I'm the president of FIRA, the Federation of International Robot Athletes, where every year we hold a competition of robots performing different sports events. That one is quite popular. Every year we have about 1,200 to 1,300 participants, and you can see some of the leagues here. So we have drones, wheeled robots, humanoid robots, and also a youth category. Now, as far as the research is concerned, there's 3 cornerstones. One is balancing, walking on 2 legs. That's a difficult problem for humanoid robots. Nowadays we can easily walk on a carpet or a wooden floor, but uneven surfaces are much more difficult. Gravel roads, path through the forest, going hiking in the mountains is beyond what our robots can currently do. Another area of research that I'm interested in is complex motion planning. The humanoid robots, because they have many degrees of freedom, have an almost infinite number of possible motions that they can execute, and only some of them will be successful. So being able to figure out which motions are going to be able to be helpful for the robot is a tough problem. And lastly, we're looking at human-robot interaction so that the robots can be controlled and work together with a human in the loop. That means that the robot needs to be able to understand speech and gestures so that interaction between the human and the robot can be natural. Another important focus of the FIRA humanoid robot competition, which is called EuroCup, is the fact that we want very versatile, flexible robots and robust robots. So we want to have a single robot that can compete in multiple events. In FIRA EuroCup, it has to compete in 10 events, including a sprint and a marathon and basketball and archery. And that makes it an interesting system design problem, because for the sprint, for example, you want to have a very light, low capacity battery because you need to run very fast. But for the marathon, you want to have a high capacity battery, but that battery is heavier, so it will impact the performance of your robot in the sprint, and you need to find the right way to balance these many different constraints that you have to be successful over all 10 events. So let's have a look at some of these events. First one I want to introduce is weightlifting. This is actually a balancing problem where the robot starts with the weight low, then walks, and then has to lift it up. So here we can watch the video. The robot walks up to the bar. Now has to use the camera to recognize the bar. It needs to move to position itself relative to the bar, so that now when he starts his pickup motion, he's able to pick up the bar. Yeah, all the motors have to be synchronized so that the roller is stable against the bar. So now he has the bar. Now it's low, the center is low, the walking gait is relatively stable. We also have a sprint event where the robot needs to run forward 3 meters and then backwards. That's why you see the robot handlers running up and down the field there. We have the EuroCup Marathon. That is our endurance event. The robot has to walk 425 meters. It's also outdoors, so it's much more challenging for the vision system. Not everything is marked by a track. Now certain parts of the track are only markers, like arrows that point the robot in the right direction to where it should walk. We play basketball. Now nobody is able to actually dribble the ball at the moment, so we're doing 3-point throws. We have archery. Here are pictures of the small robots, our kid-size class. In order to be able to detect the target, archery is mainly a problem of highly accurate detection of the target and positioning of the robot relative to the target. We use a histogram of oriented gradient feature detector in order to pinpoint the location of the target. Here's a video of our large Thormang robot doing the archery with an Olympic bow on 15 meters, and we're actually quite accurate.
Shooting!
And our goal is to be able to beat the national and international world champions of archery, hopefully in the 2022 University Games. At that time then we would have to shoot 75 meters, not 15 meters. We're also interested in robot magic as an application for human-robot interaction, because magic is all based on attention and the misdirection of attention, and I believe attention is very important for intelligence, also artificial intelligence, but has not received so much interest from the general research community. So for example, that picture here, whether you see a young lady or an old woman depends on where you pay attention to first. So here are some pictures from the robot magic show, and we have robots doing coin drops and some simple card tricks and some psychological tricks as well. We have another challenge where we're dealing with manipulation of these glass tubes. Dr. Eureka is a speed logic game for children and adults, and it's actually quite a bit of fun. And our most challenging, our most ambitious, and our most recent research problem is to try and get the Thormang robot to be able to drive an electric scooter without any modification. If that works, then we would like for the robot to be able to pass the Taiwanese driver's license test for electric scooter, which would then mean that we have the first robot that can actually pass a driving test. So on the left hand side here, we're testing precision and accuracy of the steering control at the moment. With the laser pointer, we're making sure that the robot can control the steering angle accurately. And on the right hand side, it shows our first attempts at control of the robot. This one only in simulation, so there's a disturbance and the robot trying to correct in order to make sure that it keeps driving the scooter, that it doesn't fall off. Now, I get often asked about job prospects, and I believe robotics is a very good area to get involved in, because it makes you an excellent problem solver, because you get exposed to technologies and methodologies from mechanical engineering, electrical engineering, and computer science, rather than just a single domain. Students of mine have great careers in different areas, even though they may not be directly related to robotics. Xiaohong Liu was the director for motion capture Avatar. Another student of mine, Brian, is one of the project leads for Assassin's Creed. They work for the various tech companies, also companies in Taiwan like Garmin, Gogoro, MediaTek, well-known companies in Taiwan. Are glad to hire my students, and some of my students have also successfully started their own startup companies. So if you're interested in joining the ERC, then you need to have excellent problem solving skills. We write a lot of software in different programming languages. I don't care so much about your GPA and SAT scores. If you want to impress me, then send me an example of your previous robotics or other projects. And that's it for my little presentation today. I hope to see you possibly in the future in Taiwan. And thanks for giving me this opportunity.